So today we're going to look at polynomial division. Remember that we've been going over polynomials and we looked at some of the characteristics, we've looked at their graphs, and we also looked a little bit at factoring and how to find the zeros that way. But remember that if we have something that's a quadratic, or it has a greatest common factor, or we could factor it by grouping, we can easily factor it. But sometimes if it's not one of those things, it's not going to be as easy to factor. And so that's where polynomial division comes into play. It's going to allow us to factor or find the zeros when we can't do it just kind of by hand. So let's remind ourselves what polynomial division is. So we have this thing called the division algorithm, and it seems a little complicated, but we're going to break it down. So it says if we have an f of x and we have a d of x, and they're both polynomials, and our d of x, or the divisor, can't equal 0 because that's what we're dividing by, and the degree of d of x is less than or equal to the degree of f of x, there exists a unique polynomial q of x and r of x such that f of x equals d of x times q of x plus r of x. Now, that seems like a lot of complicated stuff, but we're just going to kind of break it down. So the first thing I want to look at is this is one way that we can write our equations, but this is mostly going to be used when our r of x equals 0, meaning that, so let's say we had something that we were dividing into, so let's say 16. So if I had 16 divided by 4, well, 16 divided by 4 gives us just 4, right? So our dividend is 16, our divisor is 4. So the other way we could write this is we could say 16 equals 4 times 4, because it goes into it evenly. We don't have to worry about a remainder. So it makes sense for us to just write it as the two factors multiplied together. However, when things don't go into it evenly, we want to use a little bit of a different notation. So notice up top we have our f of x is by itself. But instead of that, if we do have a remainder, what we're going to do is we're just going to divide everything by d of x. So notice that if I divide d of x times q of x by d of x, we would just be left with q of x, and then we have plus r of x divided by d of x. And again, this seems a little bit complicated, but again, let's go back to if I had something that looked like, say, 17 divided by 3. Well, let's think. So 3 goes into 17 5 times, and we would have a remainder of 2. So I would put that remainder over my original divisor, which is 3. Well, let's think. If I have 5 and 2/3, what that means is that I'm taking 5 and I'm adding 2/3 to it. And so we can kind of relate that. So my 5 is like my quotient. My 2 is going to be the remainder, and the 3 is my original divisor. So basically we're taking it, instead of writing it as an improper fraction, we're writing it as a mixed number. And we can kind of think of our polynomials the same way. So, continuing on. Let's remember or recall our steps for long division. So our long division steps are going to be pretty similar to our long division for just normal numbers, but there are a couple of key things that we need to make sure is true for polynomials. So the first, we need to make sure both dividend and divisor are in standard form. So remember that this means that they have to go from the biggest exponent to the smallest exponent. So another way to say that is descending order of exponents. The other thing that we need to check for is that we have no missing terms. So once we've put it in descending order by exponent, we need to make sure that there's not any specific term that's missing. And if there is, we're going to have to add placeholders of 0. And so those are the things that we're going to check for every single time that we want to do our division. So it says, divide negative 5x squared minus 2 plus 3x plus 2x to the fourth plus 4x cubed by 2x minus 3 plus x squared. So hopefully we notice that the first thing is that this is not in descending order by exponents for either our dividend, which is our first, or our divisor, which is our second. So we need to rewrite them in that descending order. So we want to go from our biggest exponent first. So we would have 2x to the fourth plus 4x cubed minus 5x squared minus 2. Sorry, I missed mine. So plus 3x minus 2. And we're dividing that by x squared plus 2x minus 3. So then we're going to set up our division. So remember that we have a radical symbol, and we're going to put our dividend on the inside. And our divisor on the outside. And then we're going to walk through it kind of like we would for a normal division. We want to start always with our first term. So we're looking at x squared and our first term of our dividend, which is 2x to the fourth. And we kind of want to think about it like, what do I need to multiply x squared by to get 2x to the fourth? Well, I would need to multiply by 2x squared. So I'm going to write that up top for my quotient. And I like to write it on top of the corresponding degree of my dividend underneath, because for me that just kind of keeps everything in line, and it's easy for me to check my work then. So remember, then we want to multiply, so we would take 2x squared, multiply that by our x squared, so I would get 2x to the fourth. Then I would take 2x squared, multiply that by 2x, which is going to be 4x cubed. And then I would take 2x squared and multiply that by negative 3. So that's going to give me negative 6x squared. and then we're going to subtract. So notice that our 2x to the fourth minus 2x to the fourth gives us 0, which is what we want. If it doesn't give us 0, then that means that we picked our quotient up top incorrectly. It also happens to be that our second term, 4x cubed minus 4x cubed, is also 0. And then we have negative 5x squared minus a negative 6x squared. So be careful, this is not negative 11x squared because we are subtracting the negative 6. So when I subtract the negative 6, it changes it to be positive. So we would have 5x squared plus negative 5x squared plus 6x squared, which gives us a positive x squared. That's a really common mistake, so we need to make sure that we're careful about that we are subtracting everything in that second line. So once I've done that, I need to bring down enough terms that it's going to fill my divisor. So notice that we have 3 terms on the outside. So for my next row, I need to have 3 terms. So that means I need to bring down both my 3x and my negative 2. And basically then we start the process over again. I'm looking at my outside first term of my divisor, so x squared, and then I'm looking at my new dividend, which is the x squared plus 3x minus 2. So I'm saying x squared needs to be multiplied by what to give me x squared? Well, that would be a positive 1. And I'm leaving a space because we didn't have any x terms, and like I said, just for me, that helps me kind of keep everything straight. So I want to multiply again, so I have 1 times x squared gives me x squared, 1 times 2x gives us a positive 2x, and 1 times negative 3 gives us negative 3. And again, remember that we are subtracting those 2 lines. So x squared minus x squared gives us 0, as it should. 3x minus 2x gives us x, and negative 2 minus a negative 3 is going to give us a positive 1. So we do have a remainder in this case, so we're going to go ahead and rewrite our answer in the form, remember, that we talked about. So it's going to be our quotient, which was 2x squared plus 1. And then we're going to add our remainder, which is x plus 1, divided by our original divisor, which was x squared plus 2x minus 3. And that would be our answer. Now, if we didn't have a divisor, a remainder, then we could just rewrite it or put our answer as 2x squared plus 1. But in this case, we do need to add in that extra remainder over our original divisor. So remember that long division is one way of doing our division for polynomials. But we do have a quicker way, which is for synthetic division. However, remember that with synthetic division, we're only allowed to do it. So notice that our divisor here is of the form x minus k. So our divisor, or what we're dividing by, has to have a degree of 1 and also a leading coefficient of 1. And so we can only do this in very specific cases. It is a much faster method than our long division. However, we still need to know how to do our long division because there will be some instances, like in the previous example, we couldn't have used synthetic division for that because our divisor had an x squared. But there are some times that we can use synthetic division. So we're going to set that up and look at kind of those steps. The biggest thing to remember about our synthetic division is that instead of subtracting as we go down, we're going to be adding as we go down. So let's go ahead and look at an example because I think that makes a little bit more sense when we're trying to look at this. Now, those two things that we talked about for the requirements of long division are also requirements of synthetic division. So remember that we need to make sure that our dividend and our divisor are both in descending order by exponent, and also we need to make sure that we don't have any missing terms. So hopefully we notice that in this case both of them are already in standard form or descending order. However, in our in our dividend, we have some missing terms. So notice that we don't have an x to the third term. So like I said, we need to rewrite that with a placeholder of 0. And this would be true even if we were wanting to do it with long division. We have to have all of our terms accounted for. So we need to make sure that all of our exponents are there. We're missing the third exponent, so we put that placeholder of 0 for that. The other thing I want to check is if I want to use synthetic division, we need to check our divisor. Is our exponent 1? It is. Is our leading coefficient 1? It is. So we are allowed to use synthetic division in this case. So when we set up our synthetic division, remember that we're going to kind of turn that radical symbol upside down. And when we set it up, we only want to use our coefficients. We don't want to put all of the x's in it because that's actually what makes it a little bit faster, is that we just put the coefficients. So notice that my coefficient for my dividend is going to be 1, then 0, -10, -2, and 4. Then when we put our number on the outside for our divisor, remember that it's actually the opposite of whatever our constant is. So we have a +3 for our constant for our divisor. So we're going to put a -3 on the outside. And that's really important to remember because by switching that sign, that's what allows us to add our terms as we go down instead of having to subtract. So remember that our first step is to always bring down our first number, which in this case is 1. Okay. Then we're going to multiply to get our next number. And we multiply that by our outside number. So we have -3 times 1, which gives us a -3. And then remember that we are going to add as we go down this time instead of subtract. So 0 plus -3 is still going to be -3. And then basically we start the whole process over again. -3 times -3 gives us a +9. I'm going to add as I go down. So -10 plus 9 gives us a -1. -3 times -1 gives us a +3. -2 plus 3 gives us a +1. And then -3 times 1 is -3. 4 plus -3 is also 1. Now remember that that last number is going to be our remainder, so I like to draw a box around it because it reminds me that I need to separate that out. And right now, our answer doesn't make a whole lot of sense. I just have a bunch of numbers. So remember that we started with polynomials. We need to end with polynomials. I need to rewrite my answer so that it makes sense. So I want to start with the farthest number, which is 1, and that's going to be our constant. So I know that I'm going to have a +1 at the end. And then basically from there, I'm going to work my way to the left. So I know that my -1 is going to be my x coefficient. So I'm going to have -x. My -3 is going to be my x squared coefficient. So I know I have -3x squared. and then my 1 is going to be my x cubed coefficient. Now, if I had more numbers, I would just kind of keep going on, but I don't, so that's going to be it. And then remember, just like before, I want to add our remainder over our original divisor. And so that would be my answer. So it was I went through all of the steps as far as the multiplying and the adding. However, if we had tried to do that one by long division, it would have been a much longer process, and it also would have gotten a little bit ugly with all of the x to the thirds and x squareds and things like that. So this is a much faster. However, you do still need to be careful with your multiplication and your addition, because it's really easy if you start going too fast to make a mistake. Alright, so two other important theorems that we have. The remainder theorem, which tells us if a polynomial f of x is divided by x minus k, the remainder is equal to f of k. So basically, instead of just like plugging 2 in for f of x, we could just use the remainder of dividing f of x by x minus 2, and that would give us the same answer. And we'll look at an example of that in just a second. The other is our factor theorem. So in order for something to be a factor of our original polynomial, that's only going to work if our remainder is 0, which makes sense because it can only be a factor, right? Just like 4 is a factor of 20, that means that when I divide 20 by 4, I get 5, and there's no remainder. Same thing with our polynomials. If I divide f of x by one of its factors, I can't get a remainder. And that's how we check to see if something is a factor or not. So it says using the remainder theorem. It says use the remainder theorem to evaluate the following function at x equals negative 2. So basically what we would want to do, instead of just saying, okay, f of negative 2, and then I'm going to plug in negative 2 into all of my numbers, what we're going to do instead is use our remainder theorem and synthetic division. So I'm going to put my negative 2 on the outside this time. Okay, so notice that this is not in a factor form as like x plus 2. It's x equals negative 2. So that's why I kept the same sign. And then on my inside, I'm going to write my quotient. Again, we need to make sure, are we in descending order? Yes. Do I have any missing terms? No. So we can just rewrite that with our coefficients, which would be 3, 8, 5, negative 7. And then we're just going to start our process. So remember, our first step is to always bring down our first number, which in this case is 3. I like to draw the arrow because it reminds me that that's where I need to start, and I don't want to multiply that by anything. So then I have negative 2 times 3 gives us negative 6. Negative 6 plus 8 gives us 2. Negative 2 times 2 gives us negative 4. 5 plus negative 4 gives us 1. Negative 2 times 1 gives us negative 2. And negative 7 plus negative 2 gives us negative 9. So just like before, I'm going to box off my last number. So that's going to be my remainder. And so because my remainder is negative 9, that also tells me that f of negative 2 is also going to be negative 9. And that's all that it's going to tell us, is whatever I would get if I just plugged in negative 2 is going to be the same. Now in this case, it wouldn't have been super hard to plug in negative 2 because I only have 4 terms. However, if you have something much larger, this method's going to be a little bit faster than just trying to plug it in or even trying to type it into our calculator. So let's look at one last example. So this is where our division comes in handy. If we have something, let's look at, so we have 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. That's a big polynomial. If we notice, I don't have any common factors for the whole thing. I can't use factoring by grouping because we don't have an even number of terms, and it's not a quadratic, so we can't factor it that way. So there's not a good way to factor it right now. So what we want to do is we're going to factor it using that synthetic division. And luckily, they give us 2 of our factors. Now, remember, hopefully, from Algebra 2, if they didn't give us our factors, we can always look at this last term, which is 18, and we know that in order for it to be a factor overall, it's going to have to be a factor of 18. So notice that 2 and 3 are both factors of 18, which is why they end up being overall factors. But we would just have to test a bunch of numbers if they didn't give us the factors. But they do in this case, which is nice, so we at least know where to start. So they say that show that x minus 2 and x plus 3 are factors, and then they want us to find the remaining factors. And we're going to go ahead and use synthetic division. So remember that this is a factor, so that means that I want to put the opposite number on the outside, so just 2. Then we want to check and make sure that our dividend is in descending order and that we don't have any missing terms, and we don't. So we're just going to write our coefficients. So we have 2, 7, -4, -27, -18. Now, we should remember that if x minus 2 is truly a factor, I should get a remainder of 0. Because they told me to show that it is a factor, if I don't get a remainder of 0, that means that I did something wrong. Now, if they just asked, is this a factor, then we could get a remainder, and then our answer would be no. But since they tell us to show that it's a factor, we know that I have to get a remainder of 0. So, like always, my first step is to bring down my 2. 2 times 2 gives us 4. 7 plus 4 gives us 11. 2 times 11 gives us 22. 22 plus -4 gives us 18. 2 times 18 gives us 36. 36 plus -27 is 9. 2 times 9 is 18. And -18 plus 18 does indeed give us 0. So an important thing to look at when we're doing these is that we don't want to do, so it says repeated division. Once I've done my first division, I don't want to use the same polynomial that I started with. I want to use my new polynomial. Or in other words, notice that because we now know that x minus 2 is a factor, we can use our quotient to tell us what our other factor would have to be. So it would be 2x to the third plus 11x squared plus 18x plus 9. Again, just starting from the 9 and working my way backwards, I know that those are going to be the coefficients for each of my x values. And the reason that I want to go ahead and rewrite that as those 2 factors is because now when I do my second division with a -3 on the outside, because they tell me that x plus 3 is a factor, I want to use that new polynomial to do my division, because then it's going to be much easier to find the remaining factors instead of starting back from where I started from at the beginning with the 2x to the 4th polynomial. So again, we want to make sure we're in descending order. We are. We want to make sure that we don't have any missing terms. We don't. So we can go ahead and just write those leading coefficients on the inside. And then we're just going to do our synthetic division again. So we want to bring down our 2. We get a -6. 11 plus -6 gives us 5. 5 times -3 is -15. Plus 18 gives us 3, times -3 gives us -9, and we end up with the remainder of 0, which again, we should, because they told us that it is a factor. So now we know that only x minus 2 and x plus 3 are factors. It also gives us our remaining factor, which is 2x squared plus 5x plus 3. And because that's a quadratic, we don't have to do any more synthetic division. We can go ahead and just say what our remaining two factors are. Using our AC method, we would do 2 times 3 gives us 6. We would break apart our middle term into 2 and 3. And if we went through all of our steps, you should get 2x plus 3 and x plus 1. So we proved that our first two factors that they gave us were indeed factors.